Smart Culture, Mathematics.
Let's take a look at this example question. Determine the equation of the cubic function below. So let's take a look at the information on this diagram. You will see that this cubic function has a turning point at -2 and 0. So the x-coordinate is equal to -2 and the y-coordinate is equal to 0. It also goes through the following point, 5 and 0, where the x-coordinate is equal to 5 and the y-coordinate is equal to 0. And the y-intercept is at y is equal to 20. So what we have to do now is we have to determine the equation of the function in the form f of x is equal to ax cubed plus bx squared plus cx plus d. So how can we go about solving this problem? So what we have to do is we have to identify the roots of the function, and then we have to build the function using the factor theorem. So the question shows us that the graph of this cubic function f with various important points labeled the x and the y-intercept. So by using this information, we need to find the equation for f, and we can do this by applying the factor theorem. Remember, the factor theorem links the roots of a polynomial with the factors of the polynomial. So each root tells us a factor of the expression. We can find the factors of the equation from the graph. For example, consider the root at x is equal to 5. So from that point, we know that f of 5 is equal to 0. We know that the y-coordinate is equal to 0. The factor theorem tells us that x minus 5 must be a factor of f of x. And the same applies to all the roots on the graph. So when one of the intercepts is also a turning point, it means that two of the roots are equal to each other. So with the roots x is equal to -2, x is equal to -2, and x is equal to 5, we can write the following. F of x is equal to a multiplied by x plus 2 multiplied by x plus 2 multiplied by x minus 5. Now let's multiply these two brackets. Let's multiply these two factors, x plus 2 and x plus 2. Then we get a trinomial, x squared plus 4x plus 4. And then we multiply this with x minus 5. And then we get x cubed minus x squared minus 16x minus 20. Now, the coefficient a is necessary because the roots alone don't tell us anything about the scale of the function along the vertical axis. Now, how can we go about calculating the value of a? We can do this with any point on the curve other than one of the x-intercepts. So in this example, we know that the y-intercept is at 0 and 20. So what we'll do is we'll substitute the x and the y values into the result from above to determine the value of a. So let's do that. We know that y is equal to 20 and we know that x is equal to 0. So then we get 20 is equal to a multiplied by -20. Then we take the -20 over to the other side because we want to isolate for a. Then we get a is equal to -1. Now that we have the value for a, we can write the equation in standard form. So let's multiply -1 with x cubed minus x squared minus 16x minus 20. That gives us -x cubed plus x squared plus 16x plus 20. So this will be the final answer. The next thing that we can now do is we can determine the turning point of this function. So we can find the coordinates of the turning point P. So what we do is we differentiate the function. So we need to figure out the coordinates of point P, which is one of the turning points of the curve. And to do this, we use the fact that the derivative at the turning points must be equal to 0. So we can differentiate the function. It will be -3x squared plus 2x plus 16. Now we can make this derivative equal to 0 and solve for the x values. So in this case, we'll use the quadratic formula. So as you can see, we get x is equal to -2 and x is equal to 8/3. Now we have two answers. And in this case, it actually makes sense because the graph has two turning points. If you take a look at this graph, which answer corresponds to point P? Since x equal to -2 is one of the roots of the function, point P must be the turning point with x is equal to 8/3. Now we need to determine the y coordinate. We only have the x coordinate. So what we do is we substitute x is equal to 8/3 back into the original function because the turning point is a point on the original curve. Remember, do not substitute back into the equation for the derivative. So then we get 1372/27, and this equals 50,81. So the coordinates of point P will therefore be 2,67 and 50,81.
And that's a wrap on today's fascinating journey through the world of knowledge. Don't forget to hit that subscribe button and join our ever-growing community of curious minds. We can't wait to embark on new educational adventures together.